Hey there, I'm Steve Brumby, and what we're talking about here now is data-driven conservation. So we've been, we've been collecting data about conservation for a very long time, and the issue is, how do we know we have enough data? If we have data, how do we know that it's actually being helpful, right? How do we actually engage with the technology communities that create new sensors, the folks who have to assemble data into useful systems, and then the folks who have to actually communicate the results of all of that work to local communities to achieve change, okay? When I was on this stage a year ago, I announced that National Geographic was looking to build a new data platform to help supply the tools to enable data-driven conservation. And the Earth Pulse platform that we're actually announcing right now is the culmination of that last year of work. So Earth Pulse is a system that's designed to bring together all of this best data, but not just produce a big vat of data. There's a number of systems already that have large amounts of data. We want to curate that data that goes from the bottoms of the oceans to space and beyond. We want to bring all that together, and we want to put it to the use of understanding, let's see, next one. Okay, to understand our species, the habitats, the impacts that our actions are having on species and habitats, and the impacts that we're having on ourselves, okay? And then to assess the impact of our responses to those pressures, which we do through protected areas. And so we have a system of information summary dashboards that are automated and provide a continually updated view of every protected area in the world and of all of the species extents and all sorts of stuff up to countries that can help inform essentially a dashboard for the planet, right? So as we move towards trying to move the international community to achieve 30% protection of the world by 2030, we want to give them the tools to do that. So right now, we're going to be joined by a series, a very distinguished panel of folks who are going to help us talk through these issues of how you achieve real practical data-driven conservation. So we're going to be joined by Katy Croff-Bell, who's an oceanographer and National Geographic Fellow, Naftali Honig, Director of Research and Development at Brumby National Park in Democratic Republic of Congo with the African Parks Network, also a National Geographic Fellow, Bronwyn Agrios, a space entrepreneur and National Geographic Fellow, and Africa Flores-Anderson, research scientist at the University of Alabama and National Geographic Explorer. Please welcome to the panel. Okay, thanks for joining us. So, first question is to Katy. So, 95% of the oceans are still essentially unexplored, right? How do we evolve beyond having very expensive crewed missions to try, crewed, C-R-E-W-E-D, missions?
They can be crude also sometimes.
to explore the rest of the volume. And if we explore the rest of the volume, what do we do with all that data?
Excellent question, Steve. So I think that it's a really exciting time for oceanography and exploration and discovery in general because there have been so many advances being made in other industries with low-cost electronics and sensors and robotics. Think about the supercomputer that is in every pocket in this room right now. That has more computing power than every computer combined that put people on the moon, right? So there's so much possibility in terms of the low-cost robotics to be able to create a truly distributed, more efficient system than we've ever had before. As you mentioned, the big ships, the big robots cost tens of millions of dollars a year to operate, and they really only look at a very small fraction of the seafloor, very, very well, mind you, with incredible detail. But we really need to cover a much, much larger area and get a sense of the lay of the land, and then send those very detailed assets back there. But as you mentioned, what do we then do with the data? And before I go on, there are a couple of projects I've been working on in the sort of low-cost robotics space. One is with the Exploration Technology Lab, the guys in the basement, and that is to use the drop cameras, you can see just sort of off the screen here, to work with communities in small island developing states to be able to explore their own deep seas. So in addition to the technologies, you also need to look at who is going to be deploying these different kinds of assets and expanding what it means to be an ocean explorer. So you can't just have a handful of PhDs, oceanographers, you also need to have a much bigger community. So we have this program going on called My Deep Sea, My Backyard, and we also have another, if we can go to the next slide, which is developing underwater Lego robots, which has been very, very fun. And we did a National Geographic student expedition last summer with these little vehicles. And so we're continuing to develop them and see what we can do to really bring these kinds of assets to students, to really everyone. But then you get to, what do you do with the data, right? I'll let Naftali.
Okay, thank you. So Naftali, science and exploration leads to new senses. When you're trying to protect areas, conservation areas in very remote and often very troubled regions of the world, what are you thinking about in addition to the sensors so that you can actually build it into a system that actually has impact?
So what you're seeing on the screen here is doing some aerial mapping. We had our friends from Virtual Wonders, Corey Jaskolski and Chris Milburn, come through a few months ago. You can see how huge Brumby is. And so obviously, yeah, it's a very vast remote landscape. This is just an example here of some imagery that was taken with those flights. This is so not only is it vast, but it's also a conflict area where we have conflict in neighboring Central African Republic and South Sudan. So this is a refugee settlement in South Sudan. And just an example here is, this is how we can conduct change detection over time. And you could imagine that we would want to do that for refugee settlements or for illegal mines. But here you can see even a small path if you look closely. And you could imagine also wanting to have wildlife collars. That's a pretty typical sensor in protected areas. And then you can imagine if you identified paths using this imagery that you might want to place a camera there. So then you have to figure out, okay, well, what do we need in terms of a camera? Or anything to detect poachers. And you have to think of the testing, right? Has it been tested before it's come out? You can't go to the hardware store if you're in the middle of the DRC. So we probably have one maybe a few hundred kilometers away, so not really ideal. You have to think of timetables. So if somebody is designing a camera for conservation or a product for conservation, we can't just wait forever for these things to come out. The pace of technological development is fast. So we need people who are interested in developing technology to respect timetables, and we also have to think about transmission. So how do you get a signal from a sensor? A lot of these places don't have mobile phone access. So we have to think of a satellite solution or a LoRa solution or something like that.
Right, and so that brings up Bronwyn, who sits out in Silicon Valley. And a lot of the technology, not so much the science sensor, but the rest of the chain that Naftali just described, the comms and the computing and the power systems that can work in remote areas, a lot of those are really dual-use technology that industry is developing, and Silicon Valley is at the center of that type of development. Where do you see the big opportunities for conservation to sort of leverage that progress that's happening without getting eaten alive by the scale of the industrial investments that are being made?
Yeah, for sure. Last week, NPR reported on a retrospective from Hurricane Michael, this Category 5 storm that ripped through Florida last year with 160 mile per hour winds. And they quoted a local mayor saying, had we known sooner that the storm was going to be so severe, everyone would have left. Accurate, timely forecasting of hurricane wind speeds can absolutely change the way we address impact. And for the past 50 years, it's really been meteorologists that look at the imagery, look at the clouds, and now make a wind speed forecast every 6 hours. So, okay, this might sound a little funny, but if you look at every storm, every year, every 6 hours, those meteorologists know a lot. And now the world has a record of all of those storms. And in our current age of AI, having a scientifically validated data set that describes Earth systems is absolute gold. So in addition to a scientist or meteorologist looking at a single image, you now have computer vision looking at an image and thousands of historical, curated, validated images that can provide accurate, timely wind speeds. So my friends at Development Seed with NASA did exactly this last year. They built an AI that detected an uptick in wind speeds for Hurricane Florence from Category 2 to Category 3 a full day before the National Hurricane Center advisory came out. That's the difference between limbs falling off of trees and the trees being completely uprooted, right? So they're using the new NOAA set of satellites called GOES that observe the entire Western Hemisphere every 5 minutes. Okay, so if we tack on an extra minute to downlink that data from 35,000 kilometers above the planet, run it through the AI, process the image, and send that forecast off to the API, in 6 minutes, we're now forecasting storms like never before. So again, we just went from 6 hours to 6 minutes. That is step function change.
Okay. So after you've done all this fancy tech and you've brought in the latest and greatest commercial off the shelf, right? Somebody still needs to actually use the result, right? So Africa, you've been out in Guatemala working with the local communities, helping them understand toxic algal blooms. What do you see as the biggest challenges to the sort of capacity building that's needed at the community level or the local governmental level to help with the adoption of these technologies so that they're actually used?
Yeah, so government instability. That's the biggest challenge we have faced. And this is Lake Atitlan, as you can see, one of the most beautiful places on earth, and no bias because I'm from there, but it is. And we are using satellite remote sensing to monitor the algae blooms that have been appearing since 2009. But with Servir, which is a partnership between NASA and USAID, we work with governments to build the capacity to use air observation data for improved decision making. And we work with governments because they are the ones who have the mandate to monitor and protect their own country's resources. And we develop systems and tools that are very useful. And then there is a high turnover of technical people and officials. So we had addressed this in different ways. One of that is involving academia more and more. So we are empowering the next generation of professionals that are going to take those positions. And the other that I think has been the success of Servir is partnering with local experts. So in Servir, we work in Africa, in Asia, and in Latin America. We just start working in the Amazonia right now. And in these regions, Servir is not a bunch of scientists back here in NASA, but they are local experts. So for example, in Eastern and Southern Africa, we partner with the Regional Center of Mapping of Resources for Development, who are from Kenya, and from the countries in Eastern and Southern Africa. And they are the ones who are providing the backstopping and working with governments, and even with this high turnover of government officials, we have a stable science and knowledge, and we co-develop tools together.
Right. So one of the real tricks to achieving impactful data-driven conservation is to open the links between the different folks who are on this panel. So, Naftali, what would you say is the biggest opportunity that you have to learn from one of the others?
I think that there is a whole new field now, especially with mapping, to do it in an integrated fashion. So I think that bringing in other people's data has never been easier, and sending out your own data has never been easier. So I think there's a ton of opportunity there to share more easily.
So Bronwyn knows a lot about that. Yeah,
definitely. To me, I think one of the big opportunities to collaborate comes from this shared DNA that I've felt the past couple days between entrepreneurs and explorers, right? Everybody in this room is obsessed with going into the unknown, right? tech entrepreneurs have the same thing. We're all looking for the best tools. And I mean, I'm working on a program right now with National Geographic Labs and to bring a kind of tighter connection between the explorers and the entrepreneurial investment community in Silicon Valley that I think will help to kind of bridge those gaps, allow for a lot of things that Naftali was just talking about as well.
I personally think could learn a lot from Africa. I'm certainly guilty of the sort of parachute science model where you bring a ship in, you do a thing, you maybe hand some people locally a hard drive, and then you go away. And so that's definitely one of the things that I would like to work on personally is how can we bring deep sea science to more people who have not been engaged in it. And so I would love to learn more from Africa about their community building and how to engage with local communities in science.
Yeah, that's what we do at Servir. And we bring the science, we are that bridge between science and an application. And we are working with a lot of scientists. We are scientists ourselves, but we also respect and acknowledge that there is wisdom and information that we need. Like everything that we generate with satellite remote sensing needs to be validated and calibrated. We need in situ observations. We need data from the field. And there is a lot of local knowledge. And for me, it's sometimes even funny to see that there are scientists working in Colombia, in Peru, that are making better use of satellite data than scientists down here, because they are actually using to take an action to identify deforestation. So but we are always open, and we like to work together. That's how Servir has come about, working together. Yeah.
Bronwyn, what would you say is the biggest myth about your piece of this? What do you think is the biggest thing the rest of the conservation community misunderstands, for example, about Silicon Valley?
One of the things that Africa and I were talking about yesterday is that she's having trouble acquiring imagery for one of her programs, right? And she can't afford it, the license isn't available, and it really just brings to light that even for academic programs or nonprofit programs, especially for commercial programs, that the economics and the business model of Earth observation aren't really very well defined, and they're still very much in flux, which I think has an impact on the community, as we've seen over the past couple of days, because there's been so many references to satellite imagery. So I think the myth is that maybe space is figured out, right? But
and I will say, for anybody who's an explorer in the audience, that there are specific programs. Any explorer wants to get some satellite imagery, come and talk to me. Okay.
Okay, Steve has it figured out.
Anybody else? What's your biggest myth? How about Naftali? I mean, people give you a sensor and say, "Hey, you must have saved all the animals by now."
Certainly, that's one myth that you can look at sensors in isolation and not see the fact that you need a sensor, you need a method to transmit that, and that you need a system to integrate that data and to analyze it. And I think another big myth is that those systems, I mean, we built out a system with a lot of help from National Geographic and from Esri. And I think a big myth there is that you need some sort of super specialization in mapping to be able to implement that in a park, when in fact you can actually train capacity locally, and you can sort of have a specialist pretty easily in each park. And nowadays the tools that are available are easy enough to learn that this type of location intelligence and sort of better, more in-depth analytics is possible in every park.
Africa?
Biggest myth? Mm-hmm. Yeah, well, definitely I will think that this thinking that data and technology itself is going to solve the biggest environmental issues that we have today. And we forget about the people that are at the core of these environmental issues. So integrating that, acknowledging that, I think that scientists have to be humble enough to recognize that we have to work together, that there is knowledge out there, and that we need it. So for me, that's one of the biggest myths. Yeah.
Katy?
I think one, maybe it's not a myth, but rather maybe a misconception.
Right.
Like you hear all the stats about 95% haven't been explored, all this stuff, and then you go to Google Earth and then you see there's the bottom of the ocean right there. And yet, the data that's there is very, very low resolution. Like you see the big bumps, you see the mid-ocean ridge, but you really don't know what is there. And so that's, I think, when you look at all these beautiful maps, they make you feel like you know what's there, but really, there's so much left to explore.
Yeah, I'm originally from Australia, which was terra incognito for a long time, but for Westerners. Okay, so final question in just 30 seconds, like lightning round. What is your most optimistic view of where we're going to be like 5 years from now? Africa?
I think it's already happening. I see this room, I see the explorers, and I see so much diversity, and that brings so much hope. I think that I really want to applaud Nat Geo's effort or work to really be diverse and giving voice to those that haven't been heard for so long. I think that we still need to do more, and for example, bring indigenous peoples it has been said here at this stage several times, but I see a change that this is the first time, so this is very positive.
Katy?
Mine's longer than 5 years, but I think that with a combination of low-cost tools, data analytics, and communities, it is very possible to have any community in the world with deep sea waters to be able to explore and understand their own resources for themselves.
Cool. Naftali?
I think that in 5 years' time, with the faster paced development of technology, I think that it's fair to say that animal tracking, so wildlife tracking and other sensors, remote sensing, various types of camera traps, I think that's going to become, and the systems that you analyze the data within, I think it's going to become much more ubiquitous and successful and useful over the next 5 years.
Right, for better and worse.
Because you guys said all the things, diversity, data analytics, ubiquitous use of technology, I'm going to say hamburgers.
Yes.
I mean, I hope everybody in this room is following the Beyond Meat's IPO. I hope that in 5 years I start seeing satellite imagery, the rebirth of jungles, and that the microsatellites tracking methane emissions are detecting, reduction in emissions because of things like Beyond Meat, like plant-based meat products that are, worth, $10 billion, on the market these days. So.
Right, an Impossible Burger too.
All
right, let's thank our panelists.